Okay, hello, Abdullah. Thank you. Just one person joined today's session. And last time we were practicing experimenting with the hyperparameters. And today we gonna learn more about the generalization about the model, how to test the model, or how to divide data into training and test set. Let's see the quick video first.
I cannot hear the sound.
Oh, excuse me. You can't hear?
It's no sound.
Ah, no sound. Maybe I should switch it. Okay. Nope.
No. Maybe just share the link.
Trying to be clever and get 100% accuracy on my training
Okay, okay.
by drawing a more complicated. So we mentioned before that just fitting our training data was not enough to be doing machine learning. Machine learning, we're really interested in generalization. Let's dive into that topic a little bit more. So here we've got a data set where we've got some spam examples here on the left and some not spam examples over on the right. If I wanted to, I could try and fit a linear model to sort of disambiguate the spam from the not spam. But any sort of linear model that I would try and fit here would end up making a little bit of error. Maybe this guy would be misclassified, or that guy would be misclassified as being on the wrong side of the line. I might decide to try and be clever and get 100% accuracy on my training data by drawing a more complicated line. Maybe it would look something like this. I'm going to go and make sure that my model is going to be super clever and get 100% accuracy. All of my training examples are now completely correctly classified. What's the issue here? Well, the issue is, what if new examples are coming in? I might end up with some new examples that the model is just not really well suited to doing a good job on. So in a sense, this model has maybe overfit our training data originally, and it doesn't do a good job of classifying new, previously unseen data. Okay, so we've seen that if our models are too complicated, that overfitting is a real problem. How can we make sure that our models are not overfit in practice? Well, let's step back and take a look at the big picture of what it is we're trying to do in machine learning. At a very abstract level, we can imagine that there's some hidden process that is giving us data. And that hidden process might be something like the process by which emails are generated as either spam or not spam, and people label them as such through their perceptions, or the process by which pictures of puppies are generated and people label them as cute or non-cute. The process could be anything that gives us data. And in general, we're not going to know the full details of that. The only thing we're going to know is the concrete examples that we get to sample from that process. So specific pieces of email or spam, specific pictures of puppies. We call those samples our data samples. Now, ideally, we would like to be able to train on a data sample and then know that it's going to do well on new draws from that hidden distribution. How will we be able to trust that? Well, one thing that we could do is we could use some nice ideas that go back as far as William of Ockham from the 14th century, our first machine learning theoretician, who developed the idea of Occam's razor, basically saying that a model should be as simple as possible. There's a whole field around this called generalization theory, and it's a fascinating field. We're not going to get into that too much in this course because we don't have to use theory. We can, in fact, use empirical stuff. And the empirical strategy we can use is to take another draw from that distribution and see how well we do. This is called using a test set methodology. So we pull one draw of data from that distribution, we train on that, that's our training set. We take another draw of data from that distribution, we call it our test set. And if we do a good job, about as well at predicting on our test set as we do on our training set, then we've got pretty good feeling that our model is going to be able to generalize well onto new previously unseen data. Now there's a couple of caveats here. This is sort of the fine print of machine learning. The first is that we are drawing our data, are drawing independently and identically from that distribution. We're not biasing ourselves in any way. The second is that distribution is stationary. It doesn't change over time. And the third, kind of implied here is that we're always pulling from the same distribution. We don't suddenly start pulling from a different one. Now, those are critical assumptions, and they sort of form the bedrock of a lot of what we do in supervised machine learning. But in practice, sometimes we do violate them. The stationarity assumption might be violated if, say, user behavior on shopping changes over the holiday season versus in the summer. And the pulling from the same distribution might change if people suddenly decide that a different breed of puppies is cute than they saw before. Fashions do change. So it's important for us to be aware of these assumptions and also to pay careful attention to our metrics anytime we know that these assumptions might be violated.
So here he discussed about the model, a little bit he touched about the model choice and the problem of overfitting. And what he suggests is that we should aim for generalization, and by dividing the data set into training set and test set, we can evaluate whether our model is accurate or not. So we should keep in mind these 3 ML fine print and be aware of some edge cases. For example, when the say distribution changes when the holiday seasons or the fashion dictates new trends. And now we're gonna do some practice. So I'll send you the link, or maybe you already found it yourself. So as usual, we have a data. Imagine it's any type of data like spam, not spam, or one species, another species. Blue dots here represent the sick trees, and orange dot represents the healthy trees. And first, we need to imagine how would we place our linear model, for example, or how would we divide the data? Maybe like this, or as he showed, we can use the curve line, but we see here that data sometimes goes into the other half, and it's difficult to predict if the new data comes that our model will distinguish between blue sick trees and the healthy trees, right? So here they, okay, so here we can see how they tried to divide the data, the 2 types of trees. But if we add more data, we see clearly that this data classification does not accurately represent the classification itself. So, for example, what we had here before, now this orange space is occupied by the sick trees. So if we have new data, then it will be classified as healthy tree. instead of the sick trees. So it means our model overfits, and this is the problem in ML. So that's why what we are going to aim is to generalize models such that when we perform the model, when we run our algorithm on our training set and perform the same analysis on the test set, it should give us approximately good result. If not, that we should change our model or change our hyperparameters. So this is it for the theory, like main concepts. And I wanted to introduce you this one, more practical exercises to use the learned material. So here is the intro to machine learning. And it requires only 3 hours to complete all and to receive the certificate. So we already know a little bit of how models work. And I think with the use of Panda, NumPy, Python, you can start some data exploration. And let's dive into the first model example. You can open any environment you have. I will open the Jupyter. Okay, I think that's enough. So first of all, we need to choose our data. We import library, pandas library, and then we specify, for example, in your studies, Abdullah, you have some data. Could you remind me the field? What are you studying?
This example is okay. Just use this example.
What?
Just use this example.
No, I mean, in your studies, in your research, what kind of data do you usually work on?
Behavior data, most behavior.
I mean, you are in a Koida lab, yeah, right?
Yes, yes.
And what type of data do you usually work on?
Behavior data.
Behavior. Okay, okay. So, for example, the mice, the behavior data, right?
Yes, yes.
Okay. So, if you have any data already ready on your computer, you can use the same code to launch your data. But we gonna do this first machine learning model on, I will do on the Melbourne data, but you can use your own, okay?
Okay.
So let's run this code. And they specify the path. So on your computer, it's gonna be another path. But we will use the Melbourne data for now. So here is just saving the path. Then we read our file, CSV file, and transform it in the form of columns. Okay. And then, so what we should see is the list of the headers. For example, the name of the suburb, address, year built, and so on. Then, if we want to see the missing data or any data, we can just inspect our table. Another thing. Okay, I have a lot of. Did I just close it?
Yes, that one. Yeah, you don't have the
Okay.
file.
Okay. So let me change it to my data, for example. Oh, that would be not the privacy issues. Okay, let's just see through this code because I don't want to show the data I have, especially not published. So they have, imagine they have the document with the Melbourne city structure. Okay, then what we're gonna do is we should inspect our data, and here I think, yeah, so we have the features, we can add some features to the data like this Melbourne data, and add, for example, new column Melbourne features, and this will be the rooms, bathroom, latitude, longitude, and so on. And to look through
Can
our
you
data.
scroll up? I was. So after importing the CSV file, what do they do? Okay.
So they just saw the column names.
Okay.
And then, is it clear here?
Yes. I see.
Then they want just to inspect the data. For example, here they have year built, the prices. They either put some column like this on a dot form, or they can insert new columns by using this square bracket form. So, for example, Melbourne features, we have Melbourne data.
So they make another data frame subset of the
yes.
data frame. Okay.
Rooms, and then they add this new data set to the Melbourne data. And to see the table itself, they put the .describe function or the head. I think we already covered this on Panda and NumPy when we wanted to see the headers only, or some 5 first rows. Yes, do you remember?
Yes.
Okay. So now that we have the data ready, we can start to define our models. And I think we didn't cover the sklearn yet, but this is the library that we're gonna use to use the model decision tree regressor. And so this Melbourne model, we define our model decision tree regressor we used when we imported, and we put the random state 1. It's just the argument for random state, I think it's just some argument we can ask here. I think what is maybe.
They explain it below.
Yeah, I want to actually run everything. Oops. So it's loading a little bit slow. Do you know the link? So this is the link. Okay. Oh, I see. So we put the random state is just to ensure that, you know, when we run the random program, random method, every time it will generate a new number. But if you state the random state 1, although this number will be random, it will be fixed for this model. So if we state random state 1, we will generate every time the same number. So I think it's just to ensure the consistency of our results. If you run or I run this program, but we can check it later. And then we fit the model. We provided X and Y. I think we didn't hear, oh, okay. So X was the rows, right? And Y is what we are interested in, yeah? So let's see what we print. So X is head and X predict the head. The predictions are the values of our rooms, especially I think this is the prices for the houses. And I think it's better to explain in the practice. Okay, it's already loaded. Okay, let's go. No code. Okay, so we imported, provided the path, we read our data, then from the binder, this is the just to check our code. Run, okay. Now we need to provide what we are interested in. So in the previous example, there was X, which represented the rooms, the dimensions of the rooms here, right? And we were interested in Y, predict the, maybe it's a price here, with predictions. That, yeah, this is the prices for these dimensions of the houses. So here we need to define the columns in dataset that find that are the target of our prediction. So what we're gonna do is write here the code. So y and predict, right?
So can I make a short recap?
Where? This one?
No, I mean, so for this is a linear regression model, right? So we have to define the independent variables in X data frame and dependent
Yes.
variables in Y data frame and put it into the SK
Yeah,
scalar.
we need to, yes.
Okay.
So for example, the first one is just print the list of columns, how we can see what data we have. Print the columns, all the columns we have.
Data frame
Maybe not
columns.
all, but the top 5, for example. So this is our home data. Okay, let's try. Home data. It's arrow. Index.
Have you import the home data?
No, we already imported data, right? Setup is complete. So we use the head as here in our previous example. If we want to see the data we have, we just print head or describe, right? We can use both describe or head.
Okay.
Okay, so now we have here the numbers, mean, standard deviation, maximum, year build. We just inspect our data first. Okay. Now, when we already know the data, we need to define here y. And then in the step 2, we're gonna define x, which gonna have which gonna store our predictive features. So what is y?
Price.
What?
Can you scroll the data again? Can you show me the data?
Yes.
Scroll to the right. Yeah, so sale price is the y-axis. Sale price.
How can we retrieve the column from the data?
df.sale price. What is the name of the in home data.sale price?
Like this?
Yes.
Okay. Now we have our y data defined. So this is what we have. And then here in step 2, okay, then actually we have here the solution if you want to check when you do it yourself. Okay, then now we have to create x. So x we're gonna store our predictive features, right? Okay, you write here.
Okay.
We have the year build, number of floors, if there is a bath, other rooms. So we need to write here the features and x. Add these features to our x. So This is what we are interested in. If you look here again, there is load area. So we defining the features we are interested in to predict the sale price, right? So first we're gonna do, as you said, create the list, the data frame, right? The list of these features. How are we gonna do this?
Square brackets and just
Just use all of this, right? Okay. I think it will work like this.
So in Python, is it better to use camel case or with underscore?
In Python, I forgot.
Which one do you prefer?
Yes,
Usually.
I think here they use the underscore. Okay, then we created the list of features. Then what else? We need to define X, add these features to our X. So it's actually similar what we saw here. We imported our data. We saw it. What does it have? Then we are interested in price of our Melbourne houses. We defined the features. Then what? We need to add these features to Melbourne data. And in our case, it's home data, right?
Yes.
Yeah, do you understand why we do this?
What? Why?
Do you understand why we do this?
Which one do you mean? This line of script or which names with S?
Yes. Yes, why we do this step?
To specify the X? I don't get your question.
Yeah, I mean, why we created this features list, and then we define X as these features, right? So actually X and our home data is almost the same data, but just a small portion of the data items.
Yes, actually X is another data frame.
Yeah, why we did it?
Why? Yeah, actually we can directly put the home data feature names in the scalar, but it will be too confusing. So we make another data frame.
I think because we are we define that the price depends on the area, the year built, number of flows.
Okay.
You know, we define features that determine the price. Okay.
Okay.
Now, before building models, they want us to review the data. So let's review. For example, let's print X and print only top few lines. How we do it? Print top few lines.
Extract head.
Okay, so we have this is our X and only top few or maybe this one, 4. Okay. Now let's specify and feed the model. So we need to import something that we didn't learn yet, but we are now already have the practical experience. So what we need to import?
I don't know the name. SK something.
Yeah. So this is the decision tree regressor, right? We imported from the library sklearn. You can see it here. sklearn tree. And import this. Okay. So we imported because we're gonna use it. Let's define the model. So we need to define the model and put the data into the model. So first of all, we imported the library, right? When we imported the library, our environment or computer knows that, okay, there is some library we're gonna use, but we actually didn't create a model yet. So in order to create a model, we need to define it, right?
Yes. Okay.
So we create a variable, which is the IO model. And our model that we're going to use is the important one, decision tree regressor. Yeah. Yes. And they say that
can you open the, I'm sorry, can you open the decision tree regressor wiki? I'm not familiar with these arguments.
Oh, okay. Let's see how we do it. We just use help, right? Because I didn't run it yet, I think. Okay. So it's a lot of information here, but we are interested only on random state. Yeah. So this is the only thing for, it says for reproducibility, we need to put random state 1 so that we always get the same results. So random state is the integer value. If none, then every time it's gonna generate the new random numbers, right? I think we can, maybe next time we should learn this in data exploration tutorial. Okay, so we imported the library. We want to, so as usual in any other function or variable, we create it, right? Instantiate the model. So we put the random state here, random state 1. Now we created our model. We defined our model. And the last step here is to feed the model. How we feed the model. A lot of information here. What do you know? What do you like? Do you know what does it mean? Feed the model.
Yeah.
Not really. So let's see example again. So here we imported our library. We defined our model. Yeah. And then feeding model, it means we want to provide the data and apply the model to this data, right? We have X and Y, which this is our data. We have features and prices, and we want to fit whether the features fit the prices, right? The model fits our data.
Okay.
So we here should provide a model our data. How we do it? If we don't know, we just state the model and use the dot fit method. Signing in. Okay, let's do it. Let's do it. I hope. If it will be renewed, I think it's a good opportunity to recall everything that we wrote already. Am I logged in? Not yet. Okay, so what we can do is, instead of writing Melbourne model, we say, what was the name of a model? Something model fit X and Y. And then we make a prediction. We provide our model a new data, which is the X hat, for example, and we see what's gonna be our Y value. No. Oh, okay, okay. Actually, here we don't even work with any hyperparameters or reducing any loss. Okay, here we just say Iowa model fit and provide X and Y. If this wasn't run, we should run it. Run. Correct. Review data. Okay. And now random state. Feed the model. Random. Oh, I see. Spelling mistake. Okay, correct. We define our model. We feed our data. We feed model to our data. And the last thing is we need to make predictions now. How we do? We use the dot predict method, right? So what should I write here? Let's see example here. So we define our model and then we train our model, providing it some data, right? And then we predict model by putting some X values, for example, to get Y, which is our prices. So we say, okay, if the houses have this amount of rooms, these dimensions, what would be the price? That's what we do by predicting. And dot predict function or method allows us to predict the prices. So as an example says, we should just say, so this is our model, decision tree regressor, predict, and we say, if we say head, for example.
I think the name is Iowa model.
Yes. Iowa model. So we said incorrect predictions shape 5 and expect.
So with dot predict method, it's predict the y based on the x we give.
Yeah.
Predict the okay.
Yes. Anything unclear?
No. Then how we evaluate this? We have to make a plot.
You want to plot it? Yeah, we can use matplotlib library to plot the data. Actually, we can try to do something PLT or something. And I think maybe, I don't know if it works.
No. Make the predicted y maybe. From
Why?
the dot predict method, we make not. Come back to previous cells. Yes. And in the so we already have the predictions. Okay. So plt dot box plot and plot dot prediction. Oh yeah, correct. Okay. plt dot plot predictions and y.
So you want to predict, put predictions. So this is predictions. It's our expected y values. Yeah, right.
Yes, and compare it to the.
You want
data.
to compare to the actual data. So it's
yes. Why?
Yes. Okay. How can we do it?
I think why is okay.
No.
Why
I mean,
is price, right?
if you put predictions and y, it's not going to work, because on x should be, for example, some features like area, and then on y should be the prices, right?
No, I mean if they make a straight line, then it what? I don't know.
Yeah, I think here.
Yeah. Okay. So confused.
So what they suggest is to use the head method to compare the top few predictions. So they just say, we use the same data, right? So they suggest just to compare for now. It's an intro to machine learning. They suggest just to see the predicted value and compare with the initial table. So if we use the initial data, which was the home data, and So this is the sales prices. Yep, you see? It predicted perfectly the sales prices now. Do you see how they did it?
Yeah. Good enough.
Yep. Just by observing. But that's the, I think it's the simplest way of modeling and predicting the values. Do you have any question about this?
No, I want to know how to evaluate the model. How good is the model?
Okay.
They don't explain in the.
No, because this is just, so let me show you. So we just tried the first model, and I think later on and in the machine crash course, we're gonna, here you see we did the, maybe I did it myself. We did our first model, then validation, and then I think we can evaluate even here. Validation set, how can we validate and test whether our model works well or not? So I think using this, you already can use these algorithms to test your data. For example, if you have, you feed mouse something and you know its behavior, right? Then you know the weight of mouse, any features you know about the mouse, and then you provide the data about these features to the model and make predictions. What, for example, the behavior would be.
Okay, I get it.
Yeah. So you can apply this already on your data. And maybe next week, I think I'll start with more complex, not complex, but different kinds of models instead of linear regression. Okay. So that's it for today. Hope it was helpful for you and you can use this information for your studies.
Thank you.
Bye-bye.